so I did the board clear. I did keep my two independently determined graphs here, the IS graph, the MP graph, again, both of them showing the relationship between R and Y, and both of them found using ordered pair combinations when their specific markets were in equilibrium, right? The AE market in equilibrium at 2 points gave us the IS graph. The MP market in equilibrium at 2 points gave us the money market in equilibrium at 2 points gave us the MP graph. So again, we're simultaneously looking at multiple equilibriums, and whenever I combine each of these graphs onto one model, which I'm going to do, again, it is assuming then that equilibrium is occurring in both markets simultaneously. So that's what I want to do. Since both of these have the exact same axes, I can pick one up, I can overlay it right on top there. So by combining these, I would get the full ISMP model. Where I have my downward sloping IS function. Again, maybe not a perfect blanket, but fairly synonymous with the spending function. I have my horizontal MP function. Horizontal because the Federal Reserve is setting some targeted constant interest rate, some R bar. And you'll notice that where they interact with each other at that equilibrium, I've got some level of GDP in society. And our whole goal with this was, remember, being able to combine monetary policy, changing the interest rate, etc., and determine the effects in real GDP, on real GDP. So we're able to do that now with this combination. So there can be a couple of ways that these curves can change. So IS change, like I said, think about primarily brought about by spending change. Possibly, it's really commonly used to look at fiscal policy, so government policy. MP curve, anything that changes the interest rate that we had talked about. So any of those Federal Reserve actions that change the interest rate, or if the Fed allows the interest rate to be changed by money demand, but we won't really get into that. So anything that the Federal Reserve is going to do to change the interest rate. We can look at a couple of basic changes in this model really quick. We'll look at kind of the obvious one that we'd already seen in our aggregate expenditure model. What happens if spending changes? Well, if we like capturing spending in IS, an increase in spending would be represented as a shift in the IS function to IS2. And with no change in the interest rate, just additional spending, it should put pressure on GDP to rise. And you'll notice that my new intersection shows GDP going to Y2. We could also look at monetary policy curve changes and the impact there. So again, I'm going to do my ISMP model starter graph. Anytime you have a question that says show using the ISMP curve, you're going to start like this. And let's hypothetically say that the Federal Reserve does want to increase that interest rate. Right? Again, our story earlier said, hey, increasing the interest rate should put some pressure on GDP to fall. And again, we gave a story to, we added to that an asterisk that maybe that might be, you know, one of the secondary goals of the Federal Reserve is worrying about GDP. If it falls to combat inflation, maybe they have to do it. So, so maybe that goes up here, an increase in the interest rate to R2, which takes our MP function and shifts it to MP2. And of course, you'll notice that Y would then fall. The interesting thing with this model, maybe this will be kind of a hint, is that because we're looking at two separate government entities, you know, again, they love testing fiscal policy with that IS curve, and since the MP curve, the Federal Reserve, is independent from government policy, we actually can see the effects of both changes at the same time. Meaning it's not uncommon to test changes that the government is initiating, and is the Federal Reserve policy that they're utilizing at the time in agreement with the government. Remember, the Federal Reserve does not answer to the government, and if the government is engaged in some policy of of increased spending, the Federal Reserve may say, hey, we're really worried that you're spending too much and you're going to create some inflation. And they may start pulling money out of the economy, which means that you could have a scenario where IS is shifted to the right, putting pressure on GDP to rise. MP is shifted up, putting pressure on GDP to fall. And all that ends up happening is the interest rate in society goes up and maybe there's no change and maybe they cancel each other out. So we actually can look at those policies combined as well, which is one of the more beneficial uses of this model. And again, maybe hint, hint on something coming down the line for that. Okay, so I do think that the ISMP model is pretty easy. As you can see, we kind of wrapped it up in, what, about a class or so. So there's only one more model that we really want to kind of go through, again, for these growth models, and then we'll kind of assess where we're at in lectures and quarantine laws, and so on and so forth, before we determine if we're going to add more to part 4. But the last model that we want to look at, again, the last growth model, is one called the Aggregate Supply and Demand model. This is one, depending on who you had in Econ 1900, you may have been exposed to. You shouldn't have seen any of this before in 1900, but I think that Professor Gladson, I think, does do a little bit of the aggregate supply and demand model. So some of you might have seen it. For some of you, this is going to be brand new, and that's okay, because I think there's been instances of that already this semester. So first of all, ASAD, we're talking aggregate supply and aggregate demand. This is actually a very micro-based model to explain macroeconomic activity. Supply and demand, we're not even really changing our names here. All we mean by aggregate at this point is that we are aggregating all supply curves in the country, and we are aggregating all demand curves in the country. So this should look a lot like a supply and demand model. And if that's the case, then we know that we, again, have that market characteristics. I should have some, P and Q, because that's what our axes variables are in supply and demand. Well, keep in mind, we want to aggregate. So if we're aggregating our internal variables, we need to aggregate our external variables. Our axes variables, that would have been the proper term. So a lot of times it's very common to aggregate price into a price level. One of the more common ones, and you don't have to pick or assign just one, but one of the more common ones that I do see used is the CPI. So we very frequently aggregate price level into the CPI. And very easy, everyone does the same thing here. We aggregate all Q, all production, into real GDP. So in our aggregate supply and demand model, we know that we want to link these variables to show economic activity. We also can come up with a quasi-definition here. The aggregate supply and demand model shows how changes in the price level shows how changes in the price level affect real GDP. Changes in the price level affect real GDP. So why do we do this model here? Why do we do it after that aggregate expenditure model, if you will? Because that, again, that's our setup model. Just like we did with the IS curve, we can use the aggregate expenditure model to derive curves in this model, to derive aggregate demand. So that's what we want to do. We want to find aggregate demand. And to do it, we need that aggregate expenditure model again. So we're going to set this up almost the same way. We're going to use the exact same magic tricks, if you will. I'm going to take my aggregate expenditure model. I'm going to make up some values here in just a moment. I'm going to have some aggregate expenditure 1. And we're going to make another assumption here. So whenever we built this aggregate expenditure model, one thing that we didn't really address was prices. And that's actually kind of odd because whenever we were in 1900, we said, hey, our spending's got to be based on prices. That was the law of demand. But we didn't really address it when we built it. We said, hey, we can kind of base this on income. If you have money, you're going to spend it. Which means in that wonderful frame of economic understanding, that ceteris paribus from your Econ 1900 class, all else constant. Effectively, in the aggregate expenditure model, we were holding prices constant at some level. If they're constant at some level, that means the CPI is unchanging, or whichever price index you're using. So I'm just going to kind of make that up here. I'm going to say that at CPI equals, we'll go with 100. Just make it nice, easy, make it a base year. We want to know what happens as prices change. Okay, so if we kind of think about this in terms of building this model, are we on time?
11 minutes.
Okay, as we think about this and kind of building this model, what we want to do is we want to be able to kind of determine how our spending is impacted by the CPI. We effectively want to be able to derive a graph that shows our changes in Y relative to our change in the CPI.